Hi, in this playlist we're going to be looking at the Edexcel November 2018 Paper 2 Higher Tier. And I'm going to aim to complete this whole paper in roughly about 3 or 4 videos, each lasting about 20-25 minutes or so. Please do stop the video, have a go at each of the questions, compare your solutions. Should give you roughly about an hour's worth of fairly focused revision. Hope it's useful to you. If you're not sure about anything, always add a comment below. I'll always come back to you, and I look forward to seeing you inside the video. Hi, this is the 4th video in the playlist where we're looking at the November 2018 Higher Tier Paper 2 for GCSE. In the previous video we completed through to question number 17. Please do stop the video, have a go at each of these questions, compare your solutions. If you're not sure, always add a comment, I'll always come back to you. And let's just move on then with question number 18. Okay, so question number 18 deals with straight lines and coordinates and gradients and all this sort of stuff. Please do stop, have a go at this particular question. Okay, so let's read it through from, or just read the first line through. Straight line L1 passes through the points with coordinates that. Well, the reason they've told you that is because it's got basically a gradient, and it's probably likely we're going to need the gradient of it, because effectively what we've got, if you can imagine, we've got a grid there. So 4, 6 would be something like, I don't know, about there, something like that. Okay, and 12, 2 would be something like about there. Okay, so actually what I do know, just by doing a brief sketch, is that this gradient of L1 is going to be a negative gradient. Okay, so just be aware of that. I think sometimes it is quite useful to kind of draw these sketches out just to see what they look like. So let's just concentrate on working out the gradients, okay, of line L1. Well, if I look at L1, gradient is y2 minus y1 divided by x2 minus x1. Okay, so let's pop in the coordinates. Okay, so my y2 is going to be 2 and my y1 is going to be 6. So I've got 2 minus 6 all divided by x2 is 12 minus 4. Okay, so that's going to give me minus 4 over 8. So what I do know is that the gradient of line L1 is going to be minus a half. Okay, now what we could do from that now is work out actually the value of this line, because it's important to us to kind of get as much information as we can before we kind of move on to the rest of the questions. So fairly straightforwardly, you can say that at the point 4, 6, okay, we've got line L1 is y equals mx plus c. Well, I know the gradient is minus a half, so I can put in that y is 6 minus a half multiplied by 4 plus c. So that's going to give you 6 equals minus 2 plus c. So therefore c equals 8. All right, so what I do know now is that L1, the actual line, is y equals minus a half x plus 8. Okay, so that's kind of might be useful to me. I hope it is, but I know now this little intersect here is 8, and I know it goes through those 2 points. I know it's got a gradient of minus a half. Okay, let's have a look then at L2. I'm sorry about my doorbell, it will stop in a minute. L2 passes through the origin. Okay, this is important. If it passes through the origin, it means then that it's got a 0 value of c. Basically what I think is going to happen is it's going to go something like that. So this is going to be L2, and what we're being asked to find out is where these coordinates intersect, okay, which is at point P. All right, so let's have a look and see if we can find out about L2. Well, it tells us it's got a gradient of minus 3, so actually it's fairly straightforward. L2 is going to be, if you like, y equals mx plus c. Well, it's got a steeper gradient and its c-intercept is going to be 0, so y equals minus 3x. Okay, so I now know what L1 is and what L2 is. Okay, so however, we're being asked to find out where the points intersect. Well, at the points where they intersect, they both equal y. The coordinate of y is going to be the same for both of them. Okay, so we've gone along the corridor and up the stairs, and this particular point y is going to be the same at that point, as is the x coordinate. Okay, but what we can do is say that both of them are equal to y, so therefore they must both be equal to each other. Okay, so if you want to put a line in there, I'm going to write something like as they intersect, then what we can say is that minus 3x equals minus a half x plus 8. Okay, and then really it's a case of working this through until we get our value of x. So if I if I add a half x to both sides, I'm going to get minus 3x plus a half of x is going to give me minus 2.5x, and that's going to equal 8. If I divide through by minus 2.5, I'm going to get x equals 8 divided by minus 2.5. So x equals 8 over minus 2.5, so x is going to give me a value of 16 over 5, or that's going to be, if you prefer, minus 3 1/5. Okay, so in other words, what we now found out is that my value of x along here is going to be minus 3 1/5. Okay, so it's then just a case of saying, well, okay, that's fine. I now need to find my value of y. In order to find my value of y, I can plug it directly into this equation here. So I'm going to write minus 16 over 5 here. Okay, that's perfectly fine. If you want to leave it as 3.2, that's perfectly fine. Minus 3.2, that's fine as well. Okay, so to find my value of y, I'm going to go y equals minus 3 times x. Okay, which is the equation of my line. So I've got y equals minus 3 multiplied by minus 16 over 5. Okay, and again, you can use a calculator for that or just work it out longhand. It's going to give you a positive value, which is going to be 48 over 5, and that would be perfectly fine for this particular answer. It's going to be 48 over 5. Okay, so in other words, 48 over 5, very, very close to 9 3/5. Okay, so 5 goes into 48 9 times, then I got 3 remainder. Okay, so right at the very top here, it means that this point of intersect then is going to be positive value of 9 3/5. So it's negative 3 1/5, positive 9 3/5. Okay, so little bit of a difficult one there, dealing with the fractions and also kind of getting used to how these things work. Again, you look at the channel, there are some other calculations very, very similar to this one. Okay, let's have a look then at the next question, which is question number 19, and it says solve this. Okay, well, bit tricky, but basically what we're going to do is we're going to get rid of this 4 first, and I'm going to write this as 2 separate inequalities. What I'm going to say is if I ignore the less than 32, what I've got is 22 is less than m squared plus 7 over 4. Okay, well, that's no good to me. I need to know the value of m. So what I'm going to do is multiply both sides through by 4. Okay, and if I do that, I'm going to get 88 is less than m squared plus 7. I'm going to minus 7 from both sides, so I've got 81 is less than m squared. If I square root it, I've got plus or minus 9 is less than m. And that's absolutely fine for this one. Okay, so what that means then is if I move on to looking at the other side, I'm going to get m squared, I'm going to write this out actually, m squared plus 7 over 4 is less than 32. Okay, so again, I'm going to do exactly the same exercise. I'm going to multiply through by 4. So I'm going to get m squared plus 7 is less than 128. Okay, if that's the case, that's perfectly fine. Okay, so what I need to do then is minus 7 from both sides, and I get m squared is less than, I beg your pardon, m squared is less than 121, therefore m is less than plus or minus 11. Okay, so we've got two values now. We've got plus 9 is less than m, and m is less than plus 11. So I can write this as 9 is less than m, which is less than 11. That's one of my values. I can also write it as my negative values, which is minus 9 is less than m is less than minus 11. And that would be the answer to that particular question. Okay, again, a little bit of a tricky one, but you know, hopefully you're okay with these. So let's move on then. We've got 3 questions left in this particular paper. We're only 10 minutes into the video, so we'll do one more question, I think, which is one of those questions where there's just a lot of work to actually work your way through it. And like a lot of these questions, you just need to be very, very methodical in your approach and the way that you do things. Okay, so we'll hopefully finish this in about 10 minutes or so. Okay, so let's have a look. So the diagram shows frustum is made by removing a cone with a height of that, a solid cone with a height of that, frustum is blah, blah. Okay, even I'm getting bored now. Okay, so what we need to do is have a look at working out the average density of solid S of the whole thing. So let's just concentrate firstly on the frustum itself, okay? So the frustum itself is this bit here. In order to work out the density, okay, which is what they're asking for, we need to work out the mass divided by the volume. Okay, well, does that help us at all? Well, we're told that the density of the frustum is going to be 2.4 grams. Okay, we can kind of work out the mass because we can work out rather the volume because we've got basically 2 cones, and they've very helpfully given us the formula for working out the volume. So what we can do is say, well, actually I've got 2.4 grams per centimetre cubed. Mass, I don't know, but I can work out the volume by saying, well, actually it's going to be the big cone minus the little cone. Okay, so let's have a look at plugging some numbers in and see where we end up with that. Now, unfortunately, because of the video, you probably need to kind of have a look at this particular question yourself. I'll try my best to kind of move the paper up and down, but I don't want to be too disconcerting with it. Okay, so let's have a look at volume. So this is the volume of the frustum. So the volume of the big cone, okay, minus the little cone. Okay, so that's going to be equal, well, I've got a third. Remember, I'm using the formula pi, and r squared is going to be, if I go back to this, I've got a radius of 3.6. Okay, so 3.6 is going to be my radius of the big cone. So that's going to be 3.6 squared, and the height of it is going to be the overall height, which is going to be 6.4. Remember, I'm only concentrating on the big cone times 6.4. Okay, I've then got to subtract from that the volume of the smaller cone. Well, this is where hopefully I don't run out too much out of paper. I'll write at the bottom here, it's going to be minus 1/3 pi. Okay, now I need the radius of the smaller cone? Well, because we are looking at a linear relationship where this is half the height of half of this particular overall cone, then it means that the radius itself must be half. So the radius of the smaller cone is going to be 1.8. Okay, hopefully that's all right for you. Okay, so let's move on and see if we can figure that one out. So we've got minus a third pi, and we're going to use the same 1.8 ratio, but this time 1.8 squared for the radius, but this time the height is actually, remember, it's the little cone, it's going to be 3.2. Okay, so 3.2. All right, put all of that into a calculator, and just be very careful when you're putting these in calculators. Always, again, it's very useful to use brackets, but you're going to get some hugely long number of 76.00140948. Okay, which is basically the volume. And that's basically the volume of the frustrum. Okay, good. All right, so we're moving on a little bit further with that. So it allows us now to work out the mass of the frustrum, okay? Which is what's important when we're working out the average density of the whole unit. And remember, at this time, I'm only concentrating on the frustrum itself. So what I can say, and if I just move this over, so mass of frustrum. Okay, so this is my next kind of bit of information that I'm going to do. Well, I know density equals mass divided by volume. Okay, and I know my density has been given to me as 2.4. Now remember, at the moment, I'm making sure that I'm using centimeters, okay, in all of this. Okay, it's very important to make sure you check your units. Okay, my mass, I don't know, but I'm going to put in my volume, which is this one. So 76.0014 ... Okay, so therefore, if I multiply both sides by this number, I get the mass equals 2.4 times that number, which is going to be 182.40338. Oh my gosh. Okay, a long, boring number. Now, if you're using this on a calculator, what you could do is make use of the answer key, and it will kind of store this number for you. But for the purposes of the video, I'm just writing out everything, okay, and hopefully trying to show you a nice kind of logical way of doing it. So now what we know is that the frustrum itself has got a mass of 182.4 grams. Okay, so I'm happy with that. So it's now a case of taking then also the mass of the hemisphere. So what are we told about the hemisphere? Well, we're told it's density. And again, we can work out the volume by using the very helpful formula that they've put at the very top there for us. Bearing in mind it is a hemisphere, so it's going to be half of this formula. Okay, so let's have a look and see if we can figure out the hemisphere. So what we've got then is, if I kind of just create some more space here, I've dealt with now everything I need to deal with the frustrum. So now I'm going to deal with the hemisphere. So I'm just going to kind of draw it. Okay, not a particularly great drawing, but hopefully it'll give you some idea. Okay, so what I do know is that with the hemisphere, okay, again, I've got density equals mass over volume. Okay, now they've told us the density is 4.8, so I got 4.8. The mass I don't know, okay, but let's have a look and see if we can kind of figure this one out. But I do know the volume is going to be 4/3 of pi times 3.6 cubed, but again, I've got to get a half of it. So be very, very, very careful with all of these things. It's very important that you're kind of very logical in your approach, that you can even write a half times 4/3 pi r cubed. Okay, so let's pop in some numbers. I've got 4.8 equals mass divided by a half, 4/3 times pi times. Now the radius, if you go back to the picture, the radius of it, as we said before, is going to be 3.6, so it's 3.6 cubed. Okay, so when you work all of that out, what you should get is a mass of the hemisphere is going to be 469.037. Oh my gosh. So mass equals 469.037 ... Okay, so now we've got two values, haven't we? We've got our mass and we've got our mass. Mass for the frustum and mass for the hemisphere. Okay, so now we need to put all of this together and hopefully we should be able to come out with the average density. Okay, so I'm going to move on to, again, very helpfully, they've given us the next page, but what we can do is we can say, actually, I think what I'll do is I'm just going to write these out at the top of the page, okay, just so that you're absolutely clear on what numbers I'm using. So if I look at the frustum, okay, what I know about the frustum is it's got a mass of 182.40 ... So that's going to be the mass. And the volume we've got, which we worked out, if you remember, on the very first calculation, is going to be this one here, which is going to be 76.00 ... Okay, so then we've also got the hemisphere. Okay, and we worked out the mass of the hemisphere as going to be 469.037. Okay, and then we also looked at the volume of the hemisphere. So the volume of the hemisphere is going to be, where are we? It's going to be all of this number put together here. Okay, and if you work that out in a calculator, I did skip a stage there, I've just realized, but if you work that out in a calculator, you're going to get the volume of the hemisphere as 97.716 ... something. So we're in a position now where we can work out the overall density by just adding these things together and dividing them. So density equals mass divided by volume. Okay, so that's going to be 182.4 plus the hemisphere is 469.037. That's all divided by 76.0 ... plus 97.716 ... Okay, pop all that into a calculator and I should get my average density as 3.75 grams per centimeter cubed. Okay, and that is the answer to the question. So a little bit tedious, one of those types of questions where really you've got to spend a little bit of time kind of setting out your stall first, okay, using the information that you've got to work out, in this particular case, volume, okay, and mass of the frustum. Okay, once we've got the mass of the frustum and the volume of the frustum, we do exactly the same with the hemisphere to get the mass and the volume of the hemisphere, and then we put that together into one particular calculation. So we'll take a bit of time to work through those sorts of things. They are 5 marks, quite a hard-earned 5 marks, I must say. Okay, so there is only one question left on this particular one, so I think it makes sense just to finish with our final one question. Please do stop the video, have a go at the question, but I do understand if you stop the video right now because of that awful volume and density type question. But this one, I don't know, it's okay. I've come across this a few different times. Okay, so we're told that we've got A, B, R and P are 4 points on a circle, and then you've got some other 4 points on a different circle, and they intersect at points A and R. Okay, so prove that angle CAB equals angle ABC. So CAB is this one, and it equals angle ABC, which is this one. So we've got to prove that. Okay, so what I'm going to do is I'm going to say, actually, if I draw a line here, what have I got? Well, actually, there I've got an isosceles. Okay, so if I say that angle ABC, I beg your pardon, ARC, ABC, where am I? ABC, yeah, I am right. ABC, okay, is going to equal X, which is this angle here, okay? Now, I also know that ORB, angle ORB, also equals X, okay? And the reason I know that OR equals OB, and as they are both radius, okay, and therefore triangle ORB is isosceles. Okay, so hopefully that's okay for you at that particular point. Let's move on then to looking at angle CRO. Okay, so this is this angle here. Now CRO is going to equal, if I put angle CRO, is going to equal, remember this is X because it's an isosceles, so it's going to equal 180 minus X. Okay, hopefully you're all right with that. Okay, now if it's 180 minus X, then what we mean then is that angle CAB, so if I kind of draw this, I think what I'll do, just see if I can get this on the screen a bit better. Okay, so here's my circle, and I'm just now going to make a quick copy of what I've got with the cyclic quadrilateral, okay, which is there. Now remember, we've sort of dealt with this isosceles triangle, which is down there, and what we've basically said is that this is going to be X, which is the isosceles, and this angle, which is going to be angle CRO, is going to be 180 degrees minus X. Okay, hopefully you're all right with that because it's a normal cyclic quadrilateral. Okay, so if that is the case, then it must mean that this angle at the top here, CAO, is X, because angle CAO must equal X as, and if I put this in here, opposite angles in a cyclic quadrilateral add to 180 degrees. Okay, so I don't know how you feel about that, but basically that's what they're getting at. And in order to prove that angle CAB, CAB equals angle ABC, then they both must equal X. Okay, so in other words, this angle at the bottom here must equal this angle at the top here. I beg your pardon, this angle here, which is also X. Okay, so this one here at the bottom. Okay. So ABC, which is this one, okay, and the one at the top, CAB is going to be this one, okay, so they both must equal X because by virtue of this being an isosceles triangle and this being a cyclic quadrilateral. Okay, so been a very, very long haul to get through all of these questions, but I hope you found them useful. If you've managed to stick with it towards this end of the video, then you've done fantastically well. So many congratulations to you. If you're not sure about anything, always add a comment below, and I'll look forward to seeing you after I've had a cup of tea in the next video. Okay, bye-bye now.